Okay, this last lesson in chapter 8 is about three-dimensional coordinates and how to graph them, which can be just a tad bit tricky and a little bit hard to picture, but we're going to do the best we can here. And then using some three-dimensional coordinates with formulas that will become familiar to you, okay? So this is what I want you to think about. This is kind of how you think about um, three-dimensional system. Okay, you think of it sort of like as a box. Okay, so what they tell you when you do this is to kind of put your hand in a fist. Okay, and the x-axis is this distance right here. The y-axis is this distance here. And then the z is the up down. Okay, that's not very straight, but that's kind of how you get to the coordinate plane. Okay, so x, y, and z, if you think of holding your hand in a fist with your thumbs up like that. Okay, so you can see these coordinates right here. So for instance, this coordinate down here means you moved, this is a positive distance along the x-axis. If you go back this way, that's a negative distance on the x-axis. That's kind of hard to see, but that's how that is, okay? So I'm going to just clear this out so this is gone, okay? So this coordinate down here again is where I've moved a distance of x, and then I have not moved left or right at all, or up or down. So that's why that coordinate is x, 0, 0, okay? Then if I think about going over to, let's see, this coordinate over here, okay? Now all I've done is I've gone to the right. Okay, so I have not moved up first. That's why my x coordinate is 0. So I've only gone to the right, and I also have not moved up. So that's why my x value is 0 and my y value is 0, and I only have a y coordinate right there. Okay, and you can kind of follow that system as you go along, but hopefully that makes it a little bit easier to see. Okay, to get to this corner of the box, I would have to move my x value and up to get to that corner. Okay, to get to this corner of the box right here, I don't need to move left or right at all. I only need to move up to get there. Okay, so you can hopefully kind of picture that. Here's some other views that might help you sort of picture what's happening. Feel free to hit pause and check those out. Here's another view that might help you picture a little bit what's happening so that you can kind of think about this, okay? This is a little drawing lesson that is in your notes, and I will let you take time to read if you want, but I think it's going to make more sense if we actually just practice this, okay? So we are going to plot the point 3, 2, 4. Okay, so here's what that means. My x value has a positive value of 3, which means I need to move this direction on my x-axis, okay? So that's what I'm going to do. I'm going to move 3 down my x-axis. So 1, 2, 3 puts me right here so far. That's all I've done. So that would be the point 3, 0, 0, just so you know, okay? It also gives me a y coordinate of 2. That means I need to move 2 to the right. So what you're going to think about is you're going to use this scale, and you're going to move that same distance to the right. The other thing that I think makes it a little bit easier to do is if you think of finding your y value of 2 and then drawing a little line that's parallel to the x-axis, okay, and making this line go here, so you can kind of think about that. This now, right here, is the point. I have moved 3 along my x-axis. I have moved 2 along my y-axis. I have not moved up or down yet. Okay, so that point is the point 3, 2, 0. And then I have to move along my y-axis 4. So now I need to go 4 up. So I am going to go 4 up. I'm going to start right here, and I'm going to go 4 up. So I need to use the same scale that's on my y-axis. So I'm going to go like 1, 2, 3, 4 up, right? So from that point, I'm going to go 4 up. Okay, and I'm going to end up somewhere right around in there. Now, this isn't perfect, but that's about where I'm going to end up. So this point right here is the point 3, 2, 4. This is my answer. That is the coordinate for 3, 2, 4. Now, what I did, just so that you can kind of picture this a little bit better, is you can kind of see that I've started a box, okay? And that box would look something like this. This is the point 3, 2, 4 right here, just how I did it. Okay. You can also kind of label those coordinates, and we started some of them. This down here was the point 3, 0, 0. This right here is the point 3, 2, 0. This is the point 0, 2, 0. Okay. To get to this point right here, I moved 3 along the x-axis. I did not move left or right at all. And then I moved up 4. So this would be 3, 0, 4. Okay. This point right back here would just be my, I only moved up to get there. So I started here and I go up 4, and that's the only way I can get there. So that's the point 0, 0, 4. This point would mean I did not move along my x-axis, but I did move right 2 and up 4. So you can kind of see all the coordinates of the grid. This is the point 0, 0, 0 right there. Okay, so I think we've got them all labeled. And hopefully that helps you kind of picture how to get there. Okay, those can be a little bit tricky. Then we're going to look at the distance formula. You have seen this already in 2 dimensions. It's the same in 3 dimensions, except for you just add the z's to it. Okay, notice this is the only addition in 3 dimensions that's different than it was in 2 dimensions. Okay, then obviously there's the midpoint formula, same thing. Average of the x's, average of the y's, that's where it stops in 2 dimensions. Then you'll find the average of the z's when you're in 3 dimensions. Okay. So we are going to take some time here really quick to find the distance and the midpoint of these 2 points right here. Okay, so here we go. We'll start with the distance formula. So distance, remember, goes like this: x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Okay, we'll call this x1, y1, z1, x2, y2, z2. I bet you can figure all of this out without me, but that's okay, we'll just do this. Okay, so we have 4 minus 1 squared plus 5 minus 2 squared plus 6 minus 3 squared. All right, so then we have 3 squared, which is 9. 3 squared, which is 9, 3 squared, which is 9, which happens to be the case here. So we get the square root of 27, which is 3 root 3. If you want to get that as a decimal, that's about 5.2. Okay, about. So something like that. All right, so then let's do really quickly the midpoint formula. Okay, midpoint formula: average of the x's, average of the y's, average of the z's. Okay, so when we do that, it'll look like this: 1 plus 4 divided by 2, 2 plus 5 divided by 2, and 3 plus 6 divided by 2. Okay, so that becomes 5 halves, and 7 halves, and 9 halves. Okay, or if you want it as 2.5, 3.5, 4.5, that's fine too. But this is your midpoint. Okay, and then lastly, we have a formula for a sphere that you can kind of see what that looks like. And I think hopefully you can handle that. And here we go. It says find the standard equation of a sphere that's got this center. Okay, So this is basically your H value, your K value, and your L value, okay? So we'll use the formula that goes like this. And we will just simply plug all this in. Okay, so my h is 1, so this will go x minus 1 squared. My k is 2, so y minus 2 squared. My z is 3, so z minus 3 squared. And my radius is 4, so 4 squared is 16. And that's all you need to do. Okay, so that is the end of this lesson.